Do you remember when you were a little kid and used to wait in those long lines for so long just to spend those 10 minutes on your favorite amusement park ride? And the person that entered that line first get to go to that ride first, and the last person on the line would be the last one to try it. And this is exactly how queue data structures work in programming as well. It follows the first in, first out approach. Enough talking. It's time for AlgoAgarwal to explain how queue works in JavaScript visually. So as you can see, we have taken all of these numbers over here, and let's say I'm gonna create a queue. So our queue looks something like this, and this is called the front of our queue, and this is going to be the back, or we can call it rear. Now you might be thinking, what are all these functions over here? So all of these functions are responsible for manipulating our queue. Let's see them one by one. So first of all, we have enqueue. So enqueue is responsible for adding the elements inside of a queue. And if you have seen the queue in real life, we always enter a queue from the very back, right? So we're going to take 2 over here and we're going to pass it to this enqueue. Now what this enqueue is going to do, it's going to add this element from the very back of the queue. So okay, we have added it, and 2 is entered inside of our queue. Great. Similarly, we can enter 5, 3, 6, 1 and 9. And now we have entered all of the elements inside of our queue. Now second function is dequeue. So dequeue is responsible for taking out the elements from the queue. So if you remember, I mentioned queue is a first in, first out data structure. So the first element to go inside will be the first one to come out. So if we run dequeue on this queue, so this will be the element that is going to be popped first. So okay, fine. Let's remove this element from our queue. Great. Now if we run dequeue again, this is going to be the one that gets removed from our queue. Now the next function is peek, or some people also call it front. So you can call it either peek or front. So it basically what it does is it gives us the element which is at the very front of our queue. So right now, front of our queue is this. So if I remove this, since we have removed 2 elements from the queue, this is going to be the current front of our queue. So if we run peek on this or front on this, this will give us 3 right now, right? Now next we have isEmpty. So if you remember in my previous video of stack, I told you what isEmpty was. So it basically checks if the queue is empty or not. When we do dequeue, so let's say if our queue is empty, so if I remove all of the elements, so now our queue is empty, right? Now if we try to dequeue it, we won't get anything. So that's why we need to check if it's empty or not. If the queue is already empty, then we're not going to perform dequeue, right? Then we're going to give message like our queue is empty and you cannot perform dequeue. Same with peek. If our queue is empty, we cannot peek the queue, right? So this is where isEmpty is going to use. And the last function is going to be the size. So size basically tells us what is the current size of our queue. So if let's say we have 2, 5 and 6 inside of our queue, then this will have the size of 4 since it has 4 elements inside of it. And that is it. That is how the queue works. Let's go ahead and have a look at the code now. So if you watched my previous video, which was on stack, we used a class. So I'm going to define a class. So what are class? So again, as I mentioned in the previous video, class are basically the templates for creating objects in JavaScript, which you will understand as we code along. So I'm going to declare a class called queue. And inside of this, I'm going to put a constructor function. Now constructor functions are the functions which are responsible for initializing the variables inside of a class. For example, I'm going to initialize this dot items. So items will become a property of this queue class. So we can access items by doing something like queue.items, or when we later on go on to create an object from this class, then we can access this items variable by doing that obj, let's say obj.items. I'll show you as we go along in this video. So I'm going to initialize this dot items to be empty. So this is going to be basically our queue data structure, inside of which we are going to perform all of the operations that are supposed to be done inside of a queue. So okay, we have initialized our queue successfully. Now, as you saw in the visual explanation, we have multiple different functions inside of a queue like enqueue, dequeue, isEmpty, front, etc. Let's first try to implement the enqueue function. So I'm going to say enqueue. So enqueue, as you already know, takes an element and it pushes it inside of our queue. So this is our queue. So I'm going to take this, dot items dot push, and I'm going to push something inside of the queue, which is going to be our element. Okay, so this will push the items from the back of our queue. Now, how are we supposed to remove the elements? By using Dequeue function. So let's create a Dequeue function. So if you remember, in stack data structure, we used to push the elements from the same place and we used to remove the elements from the same place as well, because that was first in, last out. But in this case, we are supposed to push the elements from the rear and remove them from the front. So to remove the elements from the front, what do we use? I've mentioned this in my arrays video as well. We use shift. So, but first of all, before doing that, what we're going to check? We're going to check if this is empty. So I'm going to create a function for isEmpty, and I'll write the logic for it in just a second. For now, I'm just going to say this dot isEmpty, and if it is empty, I'm just going to say return underflow. And also one more thing that I missed. So we're using JavaScript, right? So there is no concept of overflow in it. If we were using something like Java or C, C++, those languages have restricted size of the array. But in JavaScript, our array is dynamic. We can add however number of elements inside of our array. So, but if the size of our array restricted or it was static, then we would have to add a condition over here. If the size is met, then return overflow. That is, we cannot go any further to add any elements. But that's not the case in JavaScript. That is why JavaScript is the best language in the world, right? So, okay. For Dequeue, first of all, we're going to check if this is empty, then return underflow. If this is not empty, then obviously we're going to remove something. So I'm going to say return this dot items dot shift. Shift is responsible for, if you do this, removes the first element from an array. That is our Dequeue function. Now let's write the logic for our isEmpty. So I think you already know what I'm going to write inside of it from our previous stack video. So we're just going to say return this dot length, this dot items dot length is equals to 0. If it's equals to 0, then it's going to return true, else it's going to return false. And if it does returns true over here, then we're going to return underflow, and probably we can say something like cannot perform Dequeue. Now what was our next function? Next function was front. So front function basically returns the element at the very front of the array. So this is a two-step process obviously. First of all, we're going to check if our queue is empty or not. So I'm going to say if this dot is empty, then I'm going to return no elements in the queue, right? Otherwise, we're going to simply return the front of our queue. So this dot items, and the front is 0th index. Cool. Now next we can have a function like size. So if you remember in our stack implementation, we had this size function as well. So I'm going to simply take it and probably add it over here. So size just return this dot items. Also, I realized instead of items, I can name it queue, right? That will be more appropriate. So I'm going to simply return this dot queue dot length. Size doesn't really matter, and I can use the same size over here. Oops, just like that. This dot size. Next, we can add something like that. This is an optional, and if you remember, I gave this as a homework to you guys in the previous video. Print queue. So I asked you to create a function for printing the stack. What I'm going to simply do, I'm going to take a string, let's say queue string, and I'm going to run a for loop, which is going to start from 0 and it's going to go to this dot items dot length. This dot queue dot length. I forgot. Or instead of this, I can use this size, right? It's going to go till there, and we're going to sequentially fetch all of the elements that are inside of our queue. So I'm going to say queue string, and I'm going to add it to this string. So plus equals this dot queue of I, that is the current element, plus white space, or just a space you can say. So I'm going to have all of the elements inside of this queue string over here. Probably we can separate it by something like comma, and then simply I'm going to return queue string, or maybe not even return, I'll just console log it, because that is what the intention of this thing is, right? So queue, and plus I'm going to add our queue string. Yep, just like that, and this will result in printing our complete queue. And that is it for our code. We have created a queue data structure over here. It's as simple as this. Let's go on and try to run this. I'm going to simply say const my queue equals new queue. I'm going to use this queue class. Now let's add something inside of our queue. So my queue dot enqueue. Let's add 5 and let's try to run this. I'm gonna console log this, console log, and I'll print the queue actually. So I'll just take this and I'll say my queue dot print queue, and let's try to run this. And yep, you see we have 5 inside of our queue currently. Let's try to add a few more elements. Let's add 96 and 786. Okay, let's try to run this. It's as expected. But what if we try to dequeue it? So let's say my queue dot dequeue. What it should do is it should remove this 5. That is, it should remove the element at the very front. And that's exactly what it did. Now let's try to see what is at the very front of our queue. So instead of this, I'm gonna say front, and it should give us 96. Yep, that's exactly what it gave us. And what else we have? We have size. Okay, let's go for size. Yep, that worked. Let's try to remove everything, and this should give us some error. So you know what? I'll just console log. Yep, you see, underflow cannot perform dequeue, and even if we try to do something like front, it's gonna give us error again. No, first of all, underflow from this, and no elements in the queue. So that is how you implement queue data structures in JavaScript. Now let's discuss the most asked interview questions on queues in our DSA interviews. But before moving forward, if you're preparing for your front-end interview and you would like me to help you in your front-end interview preparation, just click the link in the description down below and book a one-on-one call with me. We're going to discuss tips, tricks. I'm going to give you a lot of resources. I'm going to give you a roadmap tailored according to you to prepare for your front-end interviews. And let's say if you're already prepared for your front-end interview and you would like me to take your mock interview, I have a mock interview call as well. So click the link in the description down below and book a one-on-one call with me. Okay, so our first question is circular queue implementation. Now, what is a circular queue? We just understood what is a basic or a normal queue, right? Okay, so the question says that design your implementation of circular queue. The circular queue is a linear data structure in which operations are performed based on first in, first out. Yeah, that is what a queue follows. And the last position is connected back to the first position to make a circle. Okay, that seems interesting. And over here we can see that we have enqueue. Yep, we know what that is. Dequeue, front, isEmpty. And we have couple of extra functions like rear and isFull as well. And also you can see that this format is not what we are familiar with. So in the previous question we saw this class-based format, right? But now we're going to implement this in a functional based format. So what basically we're doing over here is we're declaring this function called myCircularQueue. And inside of it, we can declare any initial variable that we would like to declare. And then after that, we're going to assign it some prototype functions, like basically like polyfills that you can say. So we're going to say myCircularQueue.prototype. You don't need to understand all of this stuff. It's just understand that we are assigning this function back to this original myCircularQueue function. It's basically similar to how a class works. And you will understand this format as I go on to implement this in JavaScript. Okay, well, I guess we're going to have to call AlgoAgarwal to explain this one as well. Here I am again to explain how circular queue works in programming. Let's get it. Alright, so as you can see, I've taken all of these numbers again over here. And this is how basically a circular queue looks like. Let me explain. So as you can see, this is just like a queue, but in a round shape, right? But you might think that where is the front and rear of this? Okay. So this is the front and this is the rear. So initially the front and rear of a circular queue is at the same place. Let me just add the number of all of the indexes inside of it. So let's say this is the first position, this is the second position, third, fourth, fifth, and sixth, because obviously we start from 0th index. Now as you can see over here, we have all of these same functions that we used to manipulate our original queue. And these are the functions that are going to be used again to manipulate the circular queue as well. So okay, let's try to enqueue all of these elements inside of this circular queue. Alright, so I'm going to first enter 2, then 5. And as I am entering these values, the rear of this queue is shifting. So now the rear is over here. As I mentioned 3, the rear will be over here. Now I'm going to enter 6, 1, and 9. So now you can see our queue is full, and currently our front is over here and our rear is over here, right? Okay, now again you might be thinking, but how is it different from a normal queue? Okay, now is the fun part. Now, if I try to dequeue anything from it, so obviously when we run a dequeue function, we have to remove it from the front, right? So I'm going to remove it from right over here. And the front of our queue will now be this one over here. But do you know what's gonna happen now? Now we have an empty space inside of this queue. Okay, one more thing that I forgot to mention, that a circular queue has a fixed amount of space. Unlike a normal queue can have, in JavaScript, a normal queue doesn't have any fixed size, right? Unless we specifically assign it a fixed size. But in a circular queue, we do have a fixed size. So we are limited by the constraint of our size. So when there was a element 2 over here, right, then the queue was full and we cannot enter any more elements. So now that we have removed 2 from our queue, now we have an empty space to enter more elements. We can, let's say, I don't know, let's take 88 over here. I can enter this number over here, and now this will be our rear. So this is how a circular queue works. If you remove this from here, again we'll have an empty space inside of our queue and we can enter more elements inside of it. Now, apart from all of these 3 functions that we have in our traditional queue, we have more functions. Just like front, we have a function called rear, which helps us check which element is currently at the rear of our queue. And similar to isEmpty, we have a function called isFull, which is a self-explanatory, I guess, which helps us check if this circular queue is full or not. Now back to you, roadside coder, for explaining the code for this. Okay, now that you know what a circular queue is, let's go on and implement this in JavaScript with our code. So first of all, we can see over here, we have this function called myCircularQueue, and it gives us this variable k. Now k is basically the size of the array. So I'm gonna say size. We're going to do 2 things over here. We're going to first define our queue. So this dot queue and this dot size equals k. Now, as you already know now, that circular queue is not dynamic. It has a fixed size. So that is why we are given this k, which will define a fixed size for our circular queue. Cool. So this is how we're going to initialize it. Let's go on and implement this enqueue function. So usually how do we use to implement the enqueue is, we just would say this dot queue dot push, and that's it. Yeah, okay, fine. We're gonna do that again over here. This dot queue dot push, and we're gonna give this value. But there is a constraint over here, as you know. We have a fixed size, so that means we'll have to check if the queue is already filled or not. So I'm gonna say, or go over here and say if this dot size is equals to this dot queue dot length. If that is the case, that means the queue is already full. So I'm gonna return false. You can return false or you can return some message as well, doesn't really matter. I'm returning false over here. It's because we're gonna run this code in LeetCode, and LeetCode's test case require us to return false instead of some message. Cool. But if that is not the case, then we're gonna say this dot queue dot push, and I'm gonna simply say return true. Right? Cool. That's convenient. Now let's go on and understand Dequeue. So normally in Dequeue, how does it look like? We're just gonna say this dot queue dot shift, and it would remove the element from the front of the queue, right? Okay, fine. We're gonna take this and I'm gonna enter this over. I'm not gonna return this right now, and we're gonna return true, that this operation has performed successfully. And again, as I mentioned, I'm returning true and false. It's because the LeetCode's test cases require us to do that. So let me just show you. So if we go to LeetCode over here, we have initialized a new circular queue over here with 3 of size 3, right? And then we are pushing something inside of it. So when you push something inside of this, we return true, that the operation has been successfully performed. And you can see output is also in that format. You don't need to understand all of this just yet. I'm going to show you when we run this in LeetCode. First thing first is that you need to understand the concept and the code for circular queue. Just ignore this return true and false for now. So okay, when we try to dequeue, we do this dot queue dot shift, and it removes the element from the front of the array, right? But before that, we need to check if queue is empty or not. So I'm just gonna say if this dot queue dot length is equals to 0. If it's 0, then we're gonna return false, that this operation has failed. And also in just a minute, I'm gonna dry run this code as well, so you can better understand this, why I've used shift and why I've used push over here. Now next, we're supposed to implement this front. So it's pretty easy. So front is basically the first element of our queue, right? The front of our queue. So simply we're just gonna say return this dot queue of 0th index. Yeah, that's it. But again, we need to check if there is something inside of the queue or not. So I'm gonna add this condition over here. If queue dot length is equals to 0, then I'm just gonna return -1, that there's nothing inside of the queue. Similarly, we're gonna do this with rear as well. So simply to return rear, instead of 0th index, we're gonna return the last index. So this dot queue, oops, queue dot length minus 1. But before that, again, we need to check if there is something inside of the queue or not. So yep, same condition. All right, next is isEmpty. It's pretty straightforward, just like similar to what we did earlier. We're gonna return this dot queue dot length is equals to 0. If that is equals to 0, this is gonna return true, else it's gonna return false. Now this is something new. It is to check if the queue is filled or not. Now we have already written this condition over here. This dot size equals to queue dot length. Simply we're gonna return that. So return this dot size is equals to queue dot length. If the length of the queue is equals to the size that we got at the first place, then we're gonna return true, else we're gonna return false. Easy. Okay, let's try to run this. So we have this I've just written this template over here to understand how we're gonna write this out. So this is how you initialize a new instance of this my circular queue. So let's say if we give this size of 3, right? And if we enqueue something, let's say 1. Okay, so if we have enqueued 1 over here, let's try to console log. What do we get? I'm gonna console log the front and the backs. Object dot front comma obj dot rear, right? And I'm gonna run this circular queue. So the front and the rear is the same right now. It's 1 on 1. So okay, let's say this is our queue and we have added 1 over here, right? Let's try to enqueue something else. Let's try to enqueue 4. So again, it's gonna enter from rear, so 4. Also, let me just define the size of this array. So obviously this is going to be 3, right? These 3 spaces. So I've entered 4 now. Okay, so it should give us front as 1 and rear as 4. Okay, yep, exactly, front as 1 and rear as 4. If I try to enter something else in this, 2, it should be this now. 1 should be front, 2 should be rear. Cool. Now what if we try to enter something else? Let's say 5. You see, it won't go inside because this size is full right now. Okay, fine. So let's try to dequeue this. Obj dot dequeue. So what dequeue should do is it should remove this 1 from over here and should create space from a new element to be entered. So if we see our code for dequeue, what we're doing is we're doing this dot queue dot shift. So what shift does is it removes the element from the front of the array. So if there's 1 over here, it's gonna remove this 1 from here, and again the size of queue is now 2 and we can enter something else over here, right? Okay, now if we try to, let's say, enter 5, and now if we try to run this, yep, you see the front of the array is 4 and the back is 5. Similarly, we can do this again. If we try to dequeue this, it will remove this 4 and create a space over here, so we can enter, let's say, 72. So 72 should be over here. This is rear now, this is front now, just like that. So you see how easy it was to implement the circular queue. When we see a question like this in interviews or data structure interviews, we instantly panic. We think that, okay, what am I going to do? It looks so much complicated. But when you try to break down the question in small parts and think clearly, you're going to understand that it is much easier from what you initially thought. All right, now I'm going to take this code and try to run this on lead code. So as you can see, they have also given us with this template kind of thing. So I'm just going to replace it with my code and try to run this. There we go. Our solution has been successfully accepted. Now there are other types of queues as well, like priority queue, doubly ended queue, etc., which are not that much frequently asked but are good to know, and sometimes your interview might ask them in your data structure interviews. And if you'd like me to make a separate videos on those as well, just let me know in the comments down below and I will upload those videos next. Now the next question is to implement stack data structures using queue data structures. And trust me, this is a very important question when it comes to questions on stack and queue in our data structure interviews. So let's understand. So we're supposed to implement a last in first out stack. So if you remember from our last video, I explained how a stack data structure works. Basically, the last element to go inside of a stack is the first one to come out, or the first element to go inside of a stack is the last one to come out. So that is exactly what we are supposed to implement over here, and it should have all of the functionalities of a stack like push, pop, top, or what we also call as peek, and isEmpty or empty. Right, so we have created a basic skeleton for that over here. Fine, let's see what we're gonna do. So we're gonna take 2 queues over here. So obviously, since we're supposed to use queue data structures, we're gonna take 2 queues, and I'm gonna explain you why I've taken 2 queues over here as we go on to implement this. Now coming to the push function over here. So in a normal stack implementation, let's see how it was. So our stack implementation was over here. Okay. So in a normal stack implementation, we used to do that this.stack.push, and yeah, that's it. We're supposed to push that element inside of a stack. But over here, if we do that, so let's say if this dot, and I'm going to use q1 as our primary queue, which is going to be returned as a result at the very end. So I'm going to say this dot q1 dot push, and what are we getting over here? X. Okay. So we're going to push it. Fine. So let's say if we have this q1 over here, and we're supposed to push something. Let's say we pushed 2 inside of this. Fine. And then we have another requirement to push 3. Okay, we've pushed 3. So far so good. But let's say we're not supposed to remove something of this stack using the queue. So if we are supposed to pop it. Now stack follows last in, first out, right? So last in was 3. And so the element that was supposed to be removed should be 3, right? Not 2. But queue only can remove 2 because it follows first in, first out. So we're going to run a while loop over here, which will run until the q1 is empty. So this dot q1 dot length is not equals to 0. That is, if it's not equals to 0, then this while loop will run. What we're going to do over here, we're going to say this dot q2 dot push, and I'm going to explain you in just a minute why I'm doing this. So this dot q1 dot shift. What have I done over here? Let's take an example of q1 and q2. Let's say already we had few elements inside of our q1, which is going to be our primary queue, as I mentioned, right? So we have all of these elements. Now we are supposed to push, let's say 4 inside of it. Now we're gonna keep it in reverse order. So this q1 right now is in reverse order. It should be 5, 3, 2, and when I try to add something inside of it, it should go over here like this. But obviously queue cannot add from front. So what we're going to do, we're going to take all of these elements one by one. I'm going to remove it by using q1 dot shift, and I'm going to put them inside of our q2, right? Now that our q1 is empty, now we can take this and push it inside of our q1, right? Simply, now we're going to take all of these elements again, and I'm going to copy it inside of back inside of this q1, right? Simple enough. So yeah, we've done that. We've pushed it. Now let's copy them back inside of this q1. So I'm going to run the same while loop again. So this time I'm going to check if the q2 is empty or not. I mean, until the q2 is empty, we're going to run this, right? And I'm going to say this dot q1 dot push, this dot q2 dot shift, right? We're removing all of these elements from q2 and adding them back to q1, which will result in this array over here. And we have pushed 4 successfully inside of it. So now it gets very easy for us to pop it. So now if we want to pop it, since queue can only remove the element from the front of the array, we're gonna just have to do this dot q1 dot shift, and that's it. It will remove this 4 from it. Now we have just pushed this 4 inside of this queue, right? If we would have pushed it from over here, it would have removed 2 from it, but we have pushed it at the very front, right? So now when you try to do shift, which is what queue is supposed to do, right? While removing the elements, it is supposed to remove it from the very front. So we're going to remove 4 from it. So simply we wrote return this dot q1 dot shift. Easy. Now same for the top as well. It gets very easy for us to get the very topmost element, that is the very last element that we just pushed. We're just going to say return this dot q1 and the 0th index. And to check the empty, it's the same as before. We're going to say this dot q1 dot length is equals to 0. Then we're going to return true, that is it is empty. Else we're going to return false, that it's not empty. And that is it. Let's try to run this. Let's create a stack over here, and I'm just going to console log what is on the top right now. So obj dot, instead of obj I'm going to say stack, and I'm going to say stack dot top. If we try to run this now, we don't have anything on the top, right? So I'm going to say stack dot push. Let's push 3. Yep, you see we have 3 on the top. If we try to push 5, we have 5 on the top. Let's push a couple of more things. Okay, now we try to run this. Okay, we have 24 on the top. Now if we try to pop something, it should pop this 24. And yep, we get 96. Great. So this is how a stack should work, and we have successfully implemented our own stack by using only queues. So you see, interviewers can ask you such tricky questions during your DSA interviews to confuse you on how you're gonna do this, how you're gonna use a queue that can only remove from the front of the array and use it to implement something like stack, right? And next we're gonna discuss implementing queues using stack. But before that, let me just try to copy this and run this on LeetCode. Okay, let's paste it here and submit it. And there you have it. We have beaten 94.4% of all of the solution. That is an amazing solution. Now our next question is to implement a queue using only stacks. So the question says is to implement a first in first out data structure queue using only 2 stacks. And the implemented queue should have all of the functions of a queue, that is enqueue, dequeue, front, empty, etc. Right? So as you can see, we have a skeleton over here. Here we're gonna initialize our queue, and all of these functions should work correctly. But we are only allowed to do it by using 2 stacks. Okay, let's see how we're gonna do that. So I'm gonna initialize all of our both of our stacks over here. So this dot stack 1 equals empty. Similarly for stack 2 as well. Now how do we perform an enqueue in a normal queue? So let me this up. Yep, so in a normal queue we just do this dot queue dot push. Okay, fine, we're gonna do that over here as well because push is common in both stack and queue, right? So okay, I'll just do that and I'll just provide X to it. Fine, there's not going to be any problem while pushing anything inside of our queue. So let me just create a, let's say, example over here. So I'm going to take stack 1, and again this is going to be our primary stack, which is going to be empty, where we're going to store all of the elements of our queue, and this is going to be our second stack, right? So let's say if we're supposed to push anything in our queue by using stack. So in our stack we can, oops, sorry, this is not going to be queue. It's going to be stack 1. So to push anything inside of a queue, stack only allows us to use a push operation. Okay, let's push 5 over here. Let's say 7. Let's say 2. Okay, we have pushed 3 items, right? Let's go on dequeue. How are we gonna remove it? So if you remember, in stack, it's last in, first out. So the last one to go inside was 2. So the last one to go inside of the queue was 2. So if you're supposed to remove anything from stack, it's obviously going to be 2, right? So last in, first out. But in queue, if this 2 was the last one to go in, it's going to be last one to come out as well. So if we are supposed to run dequeue on this, it should remove 5 instead of 2, but stack is only going to remove 2, right? So let's see how we're going to do that. So I think what we can do is we can first check if there's something inside of stack 2 or not. This should be empty. When I say this dot stack 2 dot length, if this is empty, then what we will do is we will dump all of these elements inside of this stack 2. So we can take all of these one by one. First 2, 7, 5, and we're gonna store them in a reversed order and remove this from over here. Now since we have this in a reverse order, now if we try to remove something from our stack, it's going to remove 5, and that is exactly what we wanted to do. We wanted to remove the first element, right? The one at the front. So it's gonna remove 5 now. So okay, so we're gonna run a while loop over here. I'll say this dot stack 1 dot length. If it has more than one element, only then we're gonna do it. So until this has more than one element, we're gonna run this while loop. So I'll say this dot stack 2 dot push, and now to push it in a reverse order, we're not going to use shift, we're going to use pop, obviously, because stack only allows us to use pop, right? We're not going to use shift inside of it. So this dot stack 1 dot pop, right? Now this, what this will do is it will reverse the order of all of these elements and it will store inside of this stack 2. Great. Now that we have it inside of our stack 2, now we can remove the very last element. So return this dot stack 2 dot pop. Simple. And that's it. So now if we were to, let's say, add some other element inside of it, let's say if we were to add 9, so again we're gonna add inside of this 9. Okay, we've added it. Let's say we've added 10 as well. So now you see we have all of these items in different stacks. The reason for not copying all of these elements back to this stack 1 is because these are already in order. So let me show you. Now if we were to remove anything from the queue, what should it be? It should be 7, right? Because originally our order was this 5, 7, 2, right? So 5 got removed first. Now second 7 should be removed. So it makes no sense to copy these elements back to it. So now if we were gonna run dequeue again, it will do this dot stack 2 dot pop. It will not go inside of it, and it will just pop 7 right in front of over here, right? Again, if we were to pop it again, it's gonna pop 2 again. Great. Now if we were to pop again after it, then we're gonna use this array and go inside of this and reverse this and pop 9 in order, right? So this is how we're gonna implement a dequeue. This is the logic behind implementing the dequeue. Because if we were to copy all of these elements again and again back to this, it will increase the time complexity of our algorithm, right? So that is why we are optimizing it over here. And for front, what are we supposed to do? We're supposed to return this element, right? Which is at the very front. But in stack, we only return the element that is at the very last, right? That was just entered inside of this stack. So I'm gonna say same thing. I'm gonna copy all of these elements inside of it, reverse it. Oh, sorry, not pop it. I mean stack to this dot stack to dot length -1. So the last element, which after reversing this is going to be 9, right? So here we're gonna return 9. As simple as that. Now for empty, it's pretty easy. We're gonna check both of these stack if both of them are empty or not. So I'm gonna say return, and I'm gonna say if stack 1 is empty and stack 2 is empty, that is the length of both of these is 0, then we're gonna return true, else we're gonna return false. Simple as that. Now let's go on and run our queue, which was made using stacks. So I'm gonna say new my queue. I'm gonna console log the front. Right now it's gonna be empty, so I'll just push something inside of it. Queue dot enqueue3, and let's say 5 or 6, let's say. Right, so I'm gonna run this node. So the front is gonna be 3, right? I create a queue over here. We first pushed 3 and then pushed 6. So the front of the queue is gonna be 3. Now let's push 7, just like that. Still the front is going to be 3. Now if we try to remove it, Dequeue, it should be 6 now. Yep, you see 6. Also this 7 will not be here. So you see how easy it is to implement a queue using stack. Both of these questions, when asked in a DSA interviews, intimidates most of the candidates. But you see how easy it is to write the algorithm for all of these. And that is it for this video. Now in our next video, I'm gonna discuss a very important question which uses concepts of both stack and queue. So don't miss that video. That video is going to be very important. And that question is the one that a lot of these big companies like Microsoft, Google, Netflix, Amazon, etc. do tend to ask in their DSA interviews. So don't miss our next video, and give this video a huge fat thumbs up and subscribe to the channel if you want to be updated first when that video drops.